Hi everyone, happy Friday. Another time for UTA Planetarium Sky Update. My name is Levent Gürdemir, UTA Planetarium Director, and Jim Bader, Program Coordinator, is with me helping with all the stream today.
Hey, yeah, gotta push the buttons. Somebody's gotta push the buttons back here.
I think you are doing more than pushing the buttons back there.
Mostly pushing the buttons. Either way, we have a good show today. It's a good Friday.
It's a good Friday and the weather is almost perfect outside. I think it's going to be better and better towards the afternoon.
Yeah,
I
I
started
hope
seeing a
we
lot
get
of
some
sunshine.
sun. It was a little gray here. I don't know, little gray, but yes, the weather feels really nice out there.
Mhm.
Still a good day for a walk.
And we are more interested in what happens after sun goes down, right?
Definitely, that's our job. Hello, Janet, Lamia. Thank you guys for always showing up. Really appreciate that. Yeah, if you have questions about what's going on in the sky, feel free to drop them in the chat.
Yes, some of our audience is always here, every week, every time.
Yeah.
And if you are a new listener, yeah, you can put your comments on the chat, or if you have questions, and those will be answers. All right, so let's do a sky update. What is going on in the sky tonight after sun goes down? There's actually a lot going on because even before sunset, during the twilight time, the sun disappears in the horizon, but the sunlight is still leaking into the atmosphere, and the area, the environment is still a little bright. And I don't know why we are looking at a calendar, Jim.
uh, yeah.
Because I mentioned about the time, maybe the computers picked up the calendar.
Yeah, we're gonna go with that. We're gonna go. That's definitely what happened there.
And
Um,
and even before sunset, we start seeing some bright objects in the sky. And the first one is going to be the moon because it's the brightest object. And if you noticed, if you watched the video, the sky update I did 2 weeks ago, we talked about Venus and moon conjunction. The moon was right here. And just in a few weeks, you can see all the change, right? I mean, that there is a significant movement in the sky, and this is what moon do. Moon appears at a different location, not significantly different, but slightly different location every night. And the reason is the moon is orbiting around planets, our planets. All right, so, and the three objects in the sky appears, three bright objects, and the lowest one is the brightest one of the three. It's Venus. And by the way, they are all planets. Let's talk about Venus for a moment. Venus is too bright. It is also known as evening star when it is visible in the evening. Sometimes Venus is low in the sky, visible, but in the morning hours, in this case, it's also called morning star. But we know Venus is not a star. So the Venus always show us faces.
Quick update, Levin. Did you see the news about MIT's mission to Venus?
No, I have not.
Yeah. So MIT, this is not funded by NASA or ESA or anything directly, but MIT said, "Hey, we want to learn about Venus and sending spacecraft to space. There's lots of private companies that are doing this now, and it's really cheap. So they decided to just self-fund. They're gonna send a little probe to Venus. This is really awesome. And it's just gonna just. It actually feels a little silly when I say it out loud, but it's gonna skim through the atmosphere of Venus just for like 3 minutes. This is real. And it's gonna take a laser, take a bunch of data. It's gonna pass laser through things, try to get some chemistry to fluoresce different compounds, and try to see if there's anything interesting in the atmosphere, which they're looking for signs of life. Now, I don't know if you remember, NASA and ESA are both sending missions to Venus soon. But
Yes.
it's like a decade away from now, I think.
Yes. But I hope that private company check the temperature on Venus.
Yeah.
before they went. The reason is the first spacecrafts actually ended up being melted on the surface of Venus because
did.
they didn't know what was the condition, the temperature conditions on Venus. It turns out it is the hottest planet of the solar system. So if you go to Venus, you have to encounter somewhere around 900 degrees on the surface. So 900 degrees is a lot of degree, and it can melt in any, like, electronic things that just fry up the electronics. So this is what happened to the first spacecrafts. Fortunately, they were unmanned missions. There is no any manned mission planned or been done to Venus. But yeah, this is a hot planet, and the investigations are still, I'm glad, going on, because we are learning new things about planets as we explore. So Venus was, I think, abandoned for a long time. Because I haven't heard any mission until recently planned or thought about or even justified. And the reason was Venus thought to be a boring planet. It's boring because we had just know little about it. We thought, for example, volcanic activity, also surprising things we found about the volcanic activity and seismic activity on Venus. The problem with that Venus is covered by a thick atmosphere, thicker than the Earth's one. And also that atmosphere is covered by clouds. But the atmosphere is not like the air we breathe in on Earth. Its atmosphere is actually highly rich about carbon dioxide. Carbon dioxide is a poisonous gas. When you burn something, what comes out is carbon dioxide. It kills us if we breathe in. And it also has a different property. The carbon dioxide is a great blanket. I'm giving the blanket example because in a cold day, in a bed, when you cover yourself with blanket, you are trying, the blanket doesn't heat up or doesn't help heating up. It is just letting the body heat not to escape outside. So we keep warm. The blanket around, the carbon dioxide blanket around Venus works the same way. And it is not letting the heat escaping the planet. So, and it keeps getting the sunlight and keeps getting the warmth from the sun. And it is warming up to a degree, about 900 degrees on the surface. And that heat is not allowed to go outside because of the carbon dioxide. So this is also the main concern for global warming, because when the atmospheric gases increase, especially with dangerous gases like the carbon dioxide, our planet heats up too. So when our planet heats up, there's a lot of problems because we have already 75% water coverage on Earth. And what if the ice melts on the poles? Then the rest of the world may be just underwater and so on.
It's wild. I mean, to imagine the heat and temperature that they have to deal with there, but also just like anytime any scientist is going to send a spacecraft to space to learn more about whatever it is, they have to prepare for temperature changes, right? Like it gets hot when it's in the sunlight, it gets cold when it's not. And preparing someone to go to Venus, we don't like. Yeah, we're gonna have a probe that's gonna go sit in 900-degree temperature for an extended period of time is ridiculous. It just sounds like I'm very interested to see what they do to try to, manage that temperature.
Yeah. Well, this is a planet we haven't been exploring for a while. Maybe we just, forgot that planet for a while because our main focus was first the moon and then Mars. And currently, there are a lot of active missions on Mars, a lot of research being done, a lot of pictures and video, even sound being recorded on the surface of Mars.
It's so wild.
If you check the latest rover Perseverance webpage at NASA, you will find a lot of interesting archive of pictures, video, and the sound recorded from the surface. So this is a great opportunity. And hopefully, we would like to see similar missions to Venus too.
Definitely.
And Venus rotation is also, different topic. Venus rotation is unlike another planet, so it rotates pretty slowly, and it rotates actually backwards.
Yeah, pretty wild.
So in the opposite direction. So if the stars are what we call, east to west motion, daily motion, if you are sitting on Venus, it's actually in the opposite direction.
I do think it's really interesting. We just talked all this about the heat. I forgot to mention that MIT has another mission planned in 2026 to go to Venus, and they're thinking about sending, wait for it, balloon. Just because the temperature. I mean, I don't know. I mean, I'm sure that these MIT scientists are some of the best in the world. I'm sure they've got a plan to deal with that.
Well,
Anyway.
we will. It's going to be exciting to see. But yeah, this unmanned mission. I remember these times that when the manned missions stopped to the moon, people were angry about astronauts not being exploring different planets before. But if you think about it, these unmanned robotic missions actually enabled, and cost-wise, it made a lot of sense, and also enabled explorations. So nobody needs to go there. Actually, we can send robots. They have like cameras. They have microphones. They can, a lot of opportunity to communicate. Otherwise, you have to send astronaut and crewed mission. When did that change, Jim?
I don't know. I mean,
Okay,
it's
Jim
slowly
is
changed.
just correcting me. The politically, don't say manned, say crewed.
It doesn't have to be a
Okay.
man on the mission. But either way, you didn't have to
Man
tell
or
them that I was
woman,
correcting you. You're
or
supposed to say,
crewed.
"Oh, I knew that. My bad."
Let's say we put people in the missions, we
There
put
you go.
people in.
Human
And the
mission.
missions, we do not put people or any living species in. Those are called uncrewed missions. Okay, we
Sorry.
are politically correct here now.
We're talking about a sky
So,
update right now. Stargazing.
all right, we stuck on the Venus. We have to move on
Yeah.
because, Jim, I don't have time. I need to introduce some other planets too and give updates. Otherwise, I'm just exploring only or pointing only one object in the sky. The middle one is in the early hours before it really goes dark. It may be difficult to see, but it is there if you can find, especially after everything is dark. So here is Saturn. Saturn is a ringed planet. Actually, it turns out all gas giant planets have rings, but the Saturn's rings is great and visible from Earth. Even you can use a small telescope, a cheap one, and if you also good quality of pair of binoculars, also you can see the rings of Saturn. Of course, bigger the telescope, the more detail you see. This is the second largest gas giant. The rings are amazing to just look. It is great, and these rings are actually very thin. It's a very thin disk, and inside the rings there are a lot of particles, dust, small rock, etc. So you can find all kinds of stuff. But here is Saturn. This is my favorite telescopic object, the favorite one to look at with a telescope. I didn't say my favorite planet. It is different, and I'm not going to tell you about that. Let's put Saturn on its place. And here is the largest planet of the solar system. It appears in the sky high up, very bright, because it is the largest planet, and it is Jupiter. Jupiter has brown stripes. Those are all hurricane regions or storm regions. And right now it is behind the planet. Maybe Jim can rotate this planet a little bit so we can see. There is a feature called Great Red Spot. Great Red Spot is the storm region, also a hurricane feature. Well, if you think about hurricanes on Earth, they usually last maybe a week or two. But that hurricane on Jupiter has been going on for since we just started looking at Jupiter. We don't know how long it was, but I would say at least 400 years ago, we observed a Great Red Spot. So Jupiter is also a fast rotating planet. If we were on Jupiter, the days would be a lot shorter, about 11 to 12 hours. So it is almost like twice as fast rotating planet than Earth. So those are the planets you can see. When the planets are in the sky, and if you have access to a telescope, it is great time. Because the best thing is just to spot these planets, and on some of the planets you can also see their moons. Like if you look at Jupiter, usually there are like 4 moons around it, and if you look at Saturn also, you can see several moons around it. When you look at the Venus doesn't have any moon, so you cannot see any moon. Also, you can see our moon in the sky. If you would like to see craters and some nice features on it, that's great thing too. And I think somebody asked the question before, the moon names. A lot of moons, or the moons of the other planets, they have names. And our moon doesn't have any name. We call it the moon. The moon is here, and all other moons in the solar system do have names.
Yeah.
So let's look at Lamia's question. Are the solar system planets arranged in a disk or similar to the idea of rings around gas giants? Well, when we look at the solar system from distance, let's say we have a powerful spaceship, and we are going around the solar system to look at the configuration of the planets. What we see is actually pretty much most planets are on it. They appear like they are aligned with each other. The orbits are aligned with each other. Pretty much we are looking over at a pizza. Everything is on a disk. So everything seems pretty flat in order, except there are some exceptions. And first, I think the most popular exception is Pluto, because Pluto has a tilt that actually created some concern about the Pluto, whether it's a planet or not. But everything seems to be in a very nice order. Everything is pretty much like on a disk. Well, there's a reason for that, and this is very typical, because our understanding is stars and the planets are formed from the same material and same gas cloud. So there was a gas cloud in place of the solar system 5 billion years ago, and then this gas cloud formed the sun at the center and the planets around it. And this gas had a rotation, and that rotation slowly turned into a compressed disk, formed the sun, planets, and that is the plane of the solar system. In the sky, we call this plane ecliptic, or the projection of that plane ecliptic. So of course there are some exceptions, and exceptions are pretty understandable, because when planets started forming and they started becoming solid, there were collisions. The solar system was a lot crowded than today, and there were a lot of collisions. And these collisions knocked down some of the planets or objects out of the solar system, or they put them in a different path, or some of them started orbiting in a strange way. So that's how we explain if the object is orbiting backwards or spinning backwards or having a significantly tilted orbit. Probably it is as a result of an earlier collision in the solar system. So I hope that answers your question.
I think so. I mean,
all right.
I don't know if she was asking what you responded to, but from what I can read, you crushed it.
I think I a little bit went beyond, right?
Yeah, probably.
So this is not a solar system formation class. Solar system 101. All right, so those are not the only things in the sky you can see. Let's look at the other way. There are some great constellations because it's winter time, or we are going to the days to start the winter time, right? So in this case, let's see what is going on. I think my favorite planet is coming up. It is low in the horizon after sunset, but this is going to be higher and higher. later in time. And especially if you look around 10, 11, and maybe 12, you will see this constellation rising up in the sky at a point that it is very visible. So this is my favorite constellation. It is Orion. So it is not easy to miss Orion in the sky because all the stars in Orion are pretty bright. And there is like a 3-star lined up like this. This is called the belt of Orion. Orion in mythology, it's a hunter, big hunting man in the sky. Here is a famous star called Beetlejuice. You remember that from the movie, I guess, the Beetlejuice. And Beetlejuice is noticeably red star. It is my great astrophysics 101 lab over here. It's a orange star. So the color is actually great indicator for temperatures of stars. So when we looked at Venus, we cannot really tell how hot Venus is just by looking at it. But those are for planets. For stars, we can tell. The orange tells me Betelgeuse is classified as a cool star. I mean, it's not like freezing cold, of course, still at least a few thousand degrees on the surface, but it is classified as the cool side. So here is another star on the foot called Rigel. Rigel is a blue star, and the blue stars are hot stars. Their temperatures are ranging between like 9 to 11,000 degrees. And at the center of Orion, if you point your telescope, you will find a fuzzy object. If you have slightly bigger telescope, you will see like a cloud in space. If you have large enough telescope, you will see a great colorful picture like this. And this is Orion Nebula. Since we talked about the formation of the solar system with you just a few minutes ago, and here is an example. Here is, this cloud is not only making single star system, this is making a lot of stars, new stars, and the star systems, if we just think about all the other things forming around the stars too. So this is a stellar nursery. This is where one of the regions where stars are born. And you can see it yourself. This is great example if you are wondering about the formation of stars, how they start. They start from clouds or inside the gas clouds like these. And of course, the main ingredient in this gas is hydrogen, because hydrogen is the most abundant element in the universe, and the hydrogen what makes stars. So you can see it for yourself.
Definitely. It's just with a pair of binoculars, that still looks cool. Even if you're in a heavily populated area, just a pair of binoculars is so good looking.
Yeah.
Since we're looking right at it, Levent, we have a constellation just, I want to say above Orion, but right in this image, it's a little bit more to the left of Orion. I'm going to go ahead and light it up.
Yeah.
For you, let's light Orion up so that we can identify it.
Yeah, we must be talking about some of the area like here. Oh,
Yeah.
Yeah, right here, next to Orion.
These are the Geminids.
Gemini constellation.
Gemini, sorry.
And there is some event going on in this constellation, Geminids. So Gemini constellation known as twins. And this one actually, for most constellations, I can tell, I cannot just relate the names of the constellations to the pattern. For example, Orion, they say hunter, but I mean, to me, I would more like it if you just ignore these arms, kite. Kite is more like something I can imagine. But for Gemini, yeah, I can imagine twins, because those were just like twins, and especially the famous bright stars in Gemini constellation, Pollux and Castor. They are almost identical in the sky. So when you look at the two stars, like they are about the same and they are close to each other, yeah, it reminds me something twins going on.
Yeah, they're just red and blue. It's super cool looking. Anyway,
so what's going on in Gemini constellation? That's what I would like to know.
I mean, I guess you could go outside tonight, but on December 14th, we are having the peak. So the Gemini constellation will peak.
Mhm.
or Geminid meteor shower will peak. And the Geminids are always known as a really good meteor shower. I think they expect somewhere close to 120 this year, which is really high. The side effect is that on the 14th we have big gibbous moon. Not quite full, but it's like 80% illuminated. So
Mhm.
yeah, we can show them where to look. I think I could light that up if they want to see.
Yes.
Um, let's increase the meteors per hour to
Mhm.
20,000 just for the sake of showing you where to look.
Yeah.
Uh, they're going to be radiating from Gemini, and I can't tell you the universal time for this. Maybe you could help, Levent, but it'll be about 1 a.m. Central Standard
Mhm.
Time on the 14th.
Yeah. Well, usually the peak times are just a symbolic times because the particles are so
Yeah.
small, we cannot predict when we will hit whether a big particle system or small particle system. And also when that's going to happen. Usually give at least a few days before and after the peak time. You can still see great light show in the sky.
Yeah, definitely. Anyway, Geminids are going to peak before our next sky update, so we got to make sure and mention that.
Yes.
uh,
And also, we just passed a total solar eclipse in
oh, yeah.
that was visible. That the December 4 was the day the Earth had experienced another total solar eclipse. So, where were you then? Didn't you notice, Jim?
Of
The,
course I did.
we had total solar eclipse, and you didn't notice?
Well, where
You
was
must
it?
be sleeping during the days.
I mean, I definitely do, but more than I should. But where was the total solar eclipse?
Uh, that's what I didn't tell. So it was not visible from North America.
No.
It was not visible from Europe and Asia. It was not visible to Santa Claus at North Pole either.
That leaves only one place left.
Yes, Antarctica.
Oh.
Antarctica had, and maybe it's like the tip of South Africa, I guess. Also, we were able to experience it. But mostly it was the best viewing location was the ocean. And then in the south, the continent of Antarctica, which nobody lives there. But if we lived there, we had a great total eclipse on December 4.
I saw some images of it. I don't know if you saw any, but they were really. It was like some of the worst eclipse pictures I had ever seen. And I don't mean to say anything negative to the photographers. I'm sure they did a great job, but I guess I was reading that this time of the year in Antarctica, the way daylight works, they I guess it was a low eclipse. I don't know, low to the horizon made the images not look super good. Also a lot of clouds. Apparently there was a lot of problems, and there's not a lot of people down there, so couldn't couldn't quite get it. Brexton's here. Hello, Brexton. Um,
He says, "Hey, my Santa, I might see it."
I think Brexton does. He does Santa impersonations. Not that there's an impersonator if you're a child watching and you think Santa's real, but Brexton might be Santa Claus. I speaking. Rexon just said cloudy the other night. Couldn't see the meteor. Speaking of the meteor, did you see that event? Some people are saying it looks like it may be breaking up, which is pretty normal.
No, I have not.
I saw some astronomers speculating about some changes that it has made, and that we may not get to see it in the evening sky if it continues the path. So I don't know. I mean, it's
Yeah.
that's what happens when you see a comet. Comets are little fickle things.
Yeah, I mean, we don't know what's exactly the chemical composition is and how much of it is ice. So, and they evaporate. Sometimes they completely evaporate.
All right. Well, do we have anything else? Levin?
Well, I don't. I guess we will be back next Wednesday to Facebook and again Friday to YouTube.
Yeah. Thank you everybody for showing up.
See you next Wednesday.